Good day, viewers. Welcome back to this special edition on mathematics, and we are going to be solving the questions regarding indices with fraction notation. Indices with fraction notation. This is a very popular question that are often seen in WAEC exams and NECO exam. Even sometimes we do encounter them in JAM. Please follow me step by step as I show you how we solve questions that involving indices in respect to fraction notation. Now, the first thing you observe in this question, you discover that they have multiples of signs. They have sign. This is the addition. This is minus. This is multiplication. This is a bracket, and also this is a long divisional sign. Please take note of these signs. That's the first step. And another one you should also be careful with is that if you look at these numbers, they are related. These numbers are related. These numbers are related. So take note of these points. Before we proceed further, don't forget that you are expected to subscribe and share this video when you are done watching this video. At the end of this video, please share and subscribe so that you'll be notified when next we post subsequent video regarding this particular subject or related subject like chemistry and physics, and solving questions that are related in mathematics, chemistry and physics, and questions that are involved in WAEC, and sometimes like questions of JAM and NECO. Please, let's proceed further in solving questions like this. Now, if you observe, the second observation I made was that these numbers are related. So 3, we can convert this 2, 4, 3 to become, how to have a base of 3. And we'll convert 9 to have a base of 3. So therefore, they can be uniform. Now, how many times or how many 3 do we have in 243? Of course, you know that 3 times 3 times 3 times 3 times 3 times 3 in 5 places is 243. So that becomes that 3 raised to power 5 bracket n over 5. So we are able to reduce this value to become 3 raised to power 5. Then times 3 raised to power 2n plus 1 all over. And let's reduce this again. We have 3 raised to power 2 bracket n times 3 raised to power n minus 1. And proceed further, you discover that 5 can simply divide this. And this can multiply this, so it becomes 3 raised to power n times 3 raised to power 2n plus 1 all over 3 raised to power 2 times n becomes 2n times 3 raised to power 3 raised to power n minus 1. Now, having this fact, we discover that we can, from the law of multiplication of indices, we can multiply this out. It becomes, we pick one of these in out, we will have a value like 3 raised to power n plus 2n plus 1 over 3 raised to power 2n plus n minus 1. And if we do that, we're going to have a value of, let's take items. This becomes 3 raised to power, as n plus 2n becomes 3n plus 1 over 2n plus n becomes 3 raised to power 3n minus 1. Now we are able to simplify this value from this point down to this. Now if you want to proceed further, it can also be solved. Now, taking from this point, we can move forward to becomes, now they are both in division, so this can simply take away this. So we can have a value of 3n plus 1 over 3n minus 1. And of course, I told you, if you want to move, this, it becomes 3n plus 1 bracket 3n minus 1. And if you proceed with this, we will have a value which is 3n plus 1 bracket 3n plus 1. That is minus times minus will give you plus. And if we do this, we have a value of 3n minus 3n and plus 1 plus 1. And this can simply cancel this. Then we have 1 plus 1, which is equals to 2. So, but for exams of NECO and WAHE, you are expected to stop here. But if you are asked to simplify to the lowest end, then we can have an answer to give to become this. This is how we come to the end of this addiction and how we solve questions involving fractional notation. Please take notes of this And don't forget to always subscribe and share our video so that you'll be notified when next we post subsequent video regarding mathematics, chemistry, and physics. Do have a nice day. Thank you.